Yes, Siddhesh, good to go.
All right. Thanks, Nandeep. Good afternoon, everyone. And I hope you had a great conference so far. I would like to, first of all, thank all the organizers and Pune Tech community for inviting me to speak at this conference. In this session, I'll talk about how to build a multi-agent system with one of the open source Python framework called CrewAI. If we are already there in the conference, there was one more session similar to this covered, but here I will show you demos of how to actually build multiple agents which can work together as an autonomous team to achieve a given goal. Let me introduce myself. I am Siddhesh Prabhugaonkar. I am in this IT industry for almost 2 decades now, and I have worked in various roles as an architect, consultant, trainer, especially in the IT field for cloud, AI, and recently in generative AI field. I am a Microsoft certified trainer and I work as a AI enablement consultant at Atmosera, wherein I help clients to enable and adopt generative AI tools, applications, and so on. I speak at other conferences also. One of them was at Microsoft AI Tour. I do write about technology, upskilling, and certifications in general at my blog called Cloud Authority. Let me share a bunch of links which I will refer to in this session and which you may find useful in case you have to work with CrewAI later on. So save these links. This is what we are going to cover in this session. I'll start with what is the problem with a single AI agent? What is the case for creating a team of specialist agents so that they can autonomously try to collaborate with each other and achieve a goal? And what is the mental shift required to do that? Then we'll talk about what is CrewAI, what are the different paradigms it has, what primitives it consists of, and the components involved while creating multi-agent system. For example, agents, tasks, crew, flow, which are going to use tools and even memory. So we'll talk about all these components. I'll show you two demos in a Jupyter notebook, one to cover the basics to get everyone familiarized with the Crew AI architecture itself. And the second one will take a real life example of creating an article to be published by a news agency or a magazine wherein it involves multiple specialists to figure out what topic, then uh, write it, do the editorial review, and finally create the published artifact or article. So we are going to work with Flow, which will use two crews inside it to make this entire possible from no topic to a published article. Finally, we'll see what are the points you should consider before you ship anything to production and compare with other multi-agent frameworks out there in the market. We'll see some use cases also. Now, I'm sure you are already aware of it, but just want to get, uh, give you an idea of how an AI agent is different from a chatbot. I'm sure you have used both of them. A chatbot like ChatGPT will just respond to a prompt. It is stateless and it will perform the single given task at a time. AI agent, on the other hand, will try to achieve a goal. Maybe you just not just want to create the code, you want to also execute and check. You not only want to generate the test cases, you want to also run those test cases by creating the environment, see whether they are passing or failing, and give you the result. They can maintain the context and they can do multi-step reasoning. At the same time, they can also collaborate with other agents. And that is what we are going to see today as part of CrewAI. So when we talk of AI agent, it consists of four parts. And we should specify this clearly so that uh, it knows what is to be done. That is the goal, right? What it has to achieve, which will drive every decision. What is its role? The personality it has, so that you can shape its behavior accordingly. And it should be also able to decide what action to take autonomously, or you must have heard this in previous sessions, human in the loop, wherever required. So even though we call autonomous, you should use human in the loop whenever there are destructive or such kind of actions to reach its goal. And finally, tools. It could be data, API, or even other agents which it can invoke to maybe read data, to write data, or get some information from external system. This is what an AI agent consists of. Most importantly, it can reason, it can plan, and it can act until the goal is reached. And there is one more component we are going to talk about, LLM. I'm sure everyone is familiar with large language models because that's what has made these AI agents actually usable in various scenarios. Nowadays, we use it as. What is the problem with using single agent or a single LLM call at a time? We may want to do research, write, this could be writing an article, code, test cases, or something else. We want to also do review, analysis, and generate some reply. When you try to stuff it in a single prompt, single agent, making a single call to the underlying LLM, the quality of the output can degrade. Again, you can do a small experiment, and I do write about these experiments on my blog, Cloud Authority. Do check that out. What happens when you use a single agent, a Claude model, for example, or a GPT model, or even a local model? Again, when we talk about CrewAI, we are going to see how we can plug in any LLM. So again, the quality will collapse on every single dimension that you are trying to generate, maybe an artifact, or ask it to achieve a particular goal. Again, these are some of the problems that a single agent might encounter. For example, you might give a multi-step or a long prompt, whatever instructions you have given, it might forget or even quietly drop the earlier requirements. That is the tunnel vision. Second, I'm sure everyone is aware of context window. If you stuff everything, a lot of things in the context itself, all the files, all the tool calls, and other artifacts, your context window will blow up your token budget, and ultimately the cost you will have to pay, bear it and pay it. And at the same time, if you stuff too many things, it is also going to degrade the reasoning quality of the underlying model, and hence the quality of output will also drop. A general purpose AI agent or a single agent may not be able to do spatially all kinds of specialized tasks. A single personality or persona may be relevant for security auditing, performance optimization, or a marketing perspective, or some other specialization you can think of in your project or your application. And lastly, a single call will be a serial call. If you are including multiple agents, they can think in parallel and you can merge the output at the end. But with a single LLM call and single agent, we don't have that flexibility. Again, these are some of there are other problems also, but these are some of them. So what kind of mental shift do we need here? We might be using the same model, same tools, but instead of creating a single smarter agent, we should start building a team. To give you an example, if you want to perform a heart surgery, and maybe you can put on chat, everyone, will you go to a general physician or a cardiologist? Can you put on chat? Maybe one or two. One is general physician, two is cardiologist. To which doctor will you go? Yes, as Lipi and Nandip and others are mentioning, right? You will prefer, yeah, thanks Srujan for uh, attending here. And I think Srujan covered the multi-agent scenario earlier. So again, you will prefer to go to a specialist. Same thing here. Same thing with the AI agents also. Would you like to create a jack of all trades or specialize agents for different roles, different persona, or different tasks? That is the main reason we move to multi-agent scenarios. But before you choose that, here is a nice 2 by 2 matrix you should consider to make a decision of whether to go with a multi-agent scenario or not. For example, take this matrix on task complexity and autonomy needed. If it's a simple function call, simple code writing or simple task, it's a low complexity, low autonomy task and a single agent will be able to do that. But if the task is low complexity, high autonomy, you can use a chatbot like even ChatGPT, which can of course use web tools and other tools to give you a kind of a higher autonomy but low complexity task. Now, if the execution order is fixed of the task and predetermined, that is where we can use directed acyclic graph or a kind of a workflow. So in case of high complexity but low autonomy task, you can create a deterministic pipeline, the way we have CI/CD pipelines, right? So you create a pipeline of workflow. But if it is a high complexity, high autonomy task, an example of which we will see in the second demo, this is the sweet spot for multi-agent scenario. Again, you may evaluate and choose not just CrewAI, although we are going to learn it here in this session. You should also evaluate other multi-agent frameworks available in the market. Again, why CrewAI? Again, you can see so many of GitHub stars. It is one of the leading Python open source frameworks for orchestrating or multi-agent scenario, MIT license, and many of the Fortune 500 companies are currently using it in production. What you see below are the 4 advantages it gives us, or I would say it's a strong pillars. First is production grade flows. We'll see what a flow is. Autonomous crews, which can do the hard job. There is a bunch of many available inbuilt tools, and you can also create your own tool. And finally, enterprise security. That is non-negotiable. I've already shared you link about the documentation available. I'll also walk you through it. If you are looking at the documentation for the first time, you may get lost, but I will show you how easily you can figure out where to look and how to extract the information that you actually need. All right, the overall architecture of CrewAI consists of two primitives. or two components. One is flow, which is like a backbone of execution. It is going to manage the state. We can use pydantic models here. It is all event driven at the start, wait for the next action based on listen, or use branching using a router. Again, these are the uh, decorations we are going to see in demo. I can also use deterministic control for branching, loops, and even putting the gates. This is where I can also include some approval gate, human in the loop. Or I will also be able to persist the state, the information, so that even if there is a crash, the agent, the entire flow will be able to resume. The flow can use one or more crews and delegate it jobs. So crew is the intelligence part which has multiple agents. Each agent will have role, goal, backstory, which we are going to learn. They can autonomously collaborate with each other. They can delegate a crew can delegate the task either in sequential manner or in hierarchical manner. And of course, there should be memory for temporary storage, state management, knowledge again for retrieval augmented generation or RAG scenarios where you have external repository of data. You want to use knowledge rather than writing script to read directly. And of course, reasoning is provided by the underlying large language model, and we have flexibility to use many of them, which we are going to see. So flow is going to act like a manager. Crew is the team which will do the hard job. Same in visualization diagram format. These are again available on the documentation site. Again, you can see flow will decide which crew to invoke and when. It will manage the state also. And crew consists of one or more agents which are going to use one or more tools, and it will use LLM for reasoning, and it can perform one or more tasks. And this crew is going to work until our goal, the entire goal is reached. Again, I'm going to skip this. Okay, let me talk about the each component first, and then we will take a look at the some example of how to create this. An agent will have a role, who they are, goal, what is the goal to achieve it, backstory. Now, this term might be kind of misleading, but this is like instructions. You must have heard of instructions or uh, giving it some kind of rules or kind of a persona, behavior, or style that it should use to achieve that goal using that role. And it can, of course, use inbuilt and your custom tools. LLM is the brain through which it will do the thinking part or reasoning part, and memory for state management. Uh, Now, here is a sample code for creating an agent. Let's go through it. CrewAI is the package you are going to install, and we can import agent and other components. And using CrewAI tools, I can import one or more inbuilt tools, or there is a way to define your own tools also. So I want everyone to put on chat, what is the use of this tool, if you can guess. There is a role, senior market researcher, or some other role. What is the goal? Find competitive signal that others miss. And look at backstory. This is very, very important. 15 years writing reports for a well-known new agency and use site sources. So you give it role, personality, background of how it should behave. I can attach one or more tools, which LLM, whether memory is accessible, and whether the output should be displayed in verbose manner or not. Now, I don't see any response on the chat, but this Serper Dev tool can be used to do web search. Again, I will show you the site where you can also create a free account and get some credits to perform this POC, at least to begin with. Very important is the role, goal, and backstory. If you don't specify, if there is any ambiguity, then that agent may not be able to perform its job properly, or the output quality may even drop. So these three parameters, very, very important. Now you might ask, from where will I come to know what are these parameters? That's where we can go to the official documentation and make sure you refer to the specific version that you are using. Go to core concepts, and this defines agent, task, crew, and other components that we are going to talk about. Here, if you scroll down, you will come to know which parameter I can use, what is its type, and whether it's an optional or mandatory parameter. So from here, you can get the entire list and create your define your own agent. Next is task. First task is about researching. So I give it a description. Again, you can include some variables which you can pass at runtime. Expected output, very important. Do you want output in what format? In which file? HTML, Markdown, or something else? And which agent is going to work on this task? So you will have to define that agent before task. Secondly, the task execution may be the next task may depend on the output generated from the previous task. And the way to pass the output is simply you pass it as a context of the previous task. So this will create a kind of a chain, and the output will be automatically passed to the next task as an input. Because if you don't provide any context to these multiple tasks, they will kind of work in silos. So uh, collaboration, no team working together. So again, you will generally have a scenario wherein you will pass the context from one task to the other. When you define a crew, you can signify whether the agents will work on the task in a sequential, step-by-step manner or in a hierarchical manner. So here, first agent will be done sequentially, serially. But here, a manager agent will decide which one to invoke, whether to invoke them in parallel, and maybe get their output and then handle it. So we can define this process parameter inside the crew object. I can also either use inbuilt tools, which a list of some of them you can see on the screen, or I can also define my own custom tool. You just have to import a tool from crew.tools, CrewAI.tools. And whatever function you define, you just have to decorate with @tool and put the description very, very carefully. This has to be non-ambiguous, non-conflicting with other tools. Otherwise, wrong tool may be invoked, or a tool may not be invoked even if it is available to the agent. Okay, so be very, very careful while defining it. Similarly, the docstring. This will, so whenever these tools are defined and when they are to be used, the docstring, the description is what is passed to the LLM to decide whether to use that specific tool or not, or which tool to be used. And again, you might have your own implementation here. So this is how very easily you can define your own tool. So when we talk of Crew AI, we define the agent who is going to do the actual work, task, what kind of unit of work we want with the clear expected output. A group of agents collaborating together, that is our crew, whether sequential or parallel process. And of course, without LLM, they will not be reason or think the instructions and so on. All right, any questions so far? I'm going to show you these basic concepts in a small Jupyter notebook. Okay, let me go here. Now, let me show you should create either a Jupyter notebook or you can even do it in a Python file, a Python project. Uh, First, define these environment variables. Again, I'm using Gemini OpenAI API keys. How to get them? Again, very simple. You go to the respective platform or console of that provider. You create an account there. You can uh, add credits of around $5. You can see here I added it almost 6 months ago, not using it on daily basis, but I have used multiple times and still I have good balance left. And then you can go to usage link. I've shared these links already. You come to know what how much your consumption or usage is on a daily basis. And here you can go to serper.dev for web search. This is one of the tools. And you also get a generous free credits for using this. So again, you use the API keys from these respective links. I will also define which model I'm using or change it from one place. Okay, let's take a look at the first one. You should always create a virtual environment, activate it, and then install all the dependencies and so on. You need to install CrewAI and .env to read the environment variables from that environment file. Again, how to get the API keys from respective providers. I'm showing you two links. You can also use Claude, even local models and so on. Again, everything is available on the documentation site. So first step, install CrewAI, most important. Second, I will verify whether a particular key is present in the environment file or not. This is a verification step. If not, you should surface that as an error and not proceed with further execution as it is going to break your entire rest of the application. Surface it to the calling application or to the user. Here I'm going to do a simple test to verify whether my LLM call is successful or not. Now here you import from CrewAI LLM, agent or other component classes. You create an object of that class. You define the relevant parameters. Again, I can hard code the model or get it from environment variable. Temperature, it can range from 0 to 1. Lower the temperature, you will get fact-based deterministic output. But higher the temperature, you will start getting creative, non-deterministic output. Very important. If your API key that you have included in the environment file, if it is not following this naming convention, then you should explicitly read the API key into this parameter. So that's why I have explicitly added this. And we simply make a call and we print a response. This is successful. Next, I'm going to create an agent. This is the role, goal, backstory. So explain AI agents in simple terms. You are, and the backstory is you are an expert AI trainer teaching beginners. That's what I want this agent to do. Which LLM, whether I want verbose output or not. And I may define other parameters also. Let's see if this is also successful. Next, I define task. Again, I have to import it and then define the parameters like description. I want it to explain AI agent with two real world scenarios and also mention how many words. This is very important. Again, you must have heard of prompt engineering and other techniques. Very, very important. Maybe I want output in what format, how many maximum words, because that will also consume or impact your token usage, token budget, as well as cost. Which agent is going to work on it? What is the expected output? Again, output is two real world examples. Again, reiterating that these many words should be used. Let me execute it and the task is created. Now, my agent is created, task is created. I may have multiple agents, multiple tasks, but we are going to look at single agent first. I'm going to create a crew now. Very simple. You pass an array or a list of agents, list of tasks. There could be other parameters. And I simply use a kickoff method, either synchronously or asynchronously, and print the result. Let's execute this and see how nicely the output is also shown here. Crew execution has started. This is the ID of the current execution, which it can refer in case there is a crash or to be referred again. And there is a task. This agent has been invoked and the agent will work on the task and the agent final answer is whatever text. It is given nice examples and must be in 150 words. We can also verify that. And the task is completed and cruise execution is also completed. And this is the final output of from the agent as well as from the crew. I can also enable tracing. I have not done that. This will complicate the matter. But has everyone understood how to create basically a simple crew and make it work? Okay, perfect. Let's go back. Now, let's up our game. What I want to do is here consider any newspaper publisher or magazine publisher. They want to find out what are the current trending topics and they want to do research. So they will have hunters, they will have researchers, they will have technical writers, they will have reviewers, they will also have editors. So it's a at least 10 team a team of 10 members, human members working together. This is what we are going to uh, build a flow of wherein multiple crews with multiple agents will work together to figure out what topic and make it ready for publishing, all entirely autonomously done. So I'm going to define something called as a flow. So which will again use a state to manage the state from each execution point. And here we can use these events like start, listen, router. What's the use? Start means for this particular flow, this is the function which will be called the first. We are trying to gather a topic, find for which topic we want to write a or publish an article. Second, uh, this particular function will be invoked only when the previous one is executed successfully. So once topic is gathered, I must invoke research to which is going to use a research crew to do the research on that topic. Now, at the same time, this quality gate is going to check whether the research output is complete or does it require more research. Accordingly, it is going to return some string. That's it. That string is nothing but which next function should be called or it should be listened to. So for example, if it returns publish now, then it will invoke this particular function. Okay, so flow is also very simple. It uses some decorators and it gives you event driven architecture where each event when completed or fired, you will perform the task and maybe pass it back to the calling function or calling crew or flow. All right. Again, these are also very important parts. Memory for again short term memory will be maintained as a session. If you want a long term across runs, you can use, there is an option to use a database here. Again, it's a in-memory database, or you can also opt in with memory. There are many other things you can do. Knowledge sources. Instead of reading from a script, I will index all the documents, files, so that it will be cheaper to read the data as well as I can generate a grounded answers. Again, you can use knowledge sources as a parameter to specify all this knowledge, maybe external sources. Of course, reasoning will be done with an LLM, and you just have to set this parameter, which will enable it, the flow, to create a multi-step problem solve. All right. When will you decide how to use, when to use crew or flow? Again, a simple research task, you use a, if it is a simple job to be done, use a crew. But if it consists of a pipeline, workflow, or even a complex multi-step reasoning, you can either use flow, and in certain cases, you can see that you need to use both. In our case of creating a news article and publishing it, we will have to use both. All right. So here is what we are going to do. We'll create one flow. We'll use two crews. 5 agents will work together, and let's see what it does. Finally, what I want the article to be generated in a markdown format and saved to a particular location. That is what I want. Now, this is how it is going to work. I will start with gathering a topic. You can also specify a topic. When you create an instance of that flow, you can specify a topic or let it hunt for it. We are in fact going to ask it to hunt for a trending topic. It once it is identified, research phase will do the research. Quality gate will identify whether more research is required or ready for publishing the article. And once ready, you will create that output in a nice markdown format. This is what we are going to see in the next demo. So I have one more here. I'll just keep whatever is not required. Here I'm installing CrewAI tools. I'm going to use them. Pydantic for state management. I'm just loading the environment file and resolving the root of the same folder. I just want to show you what we have here. I have an environment file, 2 notebooks. I have saved this MD file as a backup in case things go wrong. And this is a nice flow we are going to see later. First, I am going to create a state object using Pydantic model for topic, audience, what is the research memo or output, how many word count, how many times research has to be done again, what is the final article and where the path is published, timestamp. You can define your own state object. Finally, I'm creating an object of the state with topic and audience. Okay, this is where I have configured topic and audience. Let's execute. Next, I will be using this Serper dev tool as a web search, and my tool is ready. Again, it is verifying whether the API key is present in the environment file or not. Now I'm going to build 2 crews. One is for research. Look at this crew. It consists of 3 agents. The hunter agent is going to hunt for a trending topic related to whatever topic we have mentioned. Checker agent is going to verify whether it is relevant and trending. So every output that you get, you must always verify and validate. You don't take blindly whatever the output is generated by any LLM, any chatbot, or any AI agent. And finally, analyst agent is going to synthesize the output of both, compare it, synthesize it, and create a memo which can then be used for further process. So this is just a visual picture of what we are going to define here. All right. In the next cell, I am importing agent, task, crew, process. I am defining a function which will take the LLM object and return me a crew object. I'm defining the trend hunter agent first. Look at the role, goal, and the backstory. It also will need access to web search tool or any other tools. Which LLM will be used? Whether it can delegate or this agent can delegate it to some other agent, true or false, and also verbose. We need a fact checker, validate every claim, flag anything that smells like a hallucination. I'm sure you must have heard of this problem. And look at the backstory. You work at routers. You don't ship a number you can't source. So everything has should be traceable to a particular source. One more agent, analyst, turn these findings into a tight insight memo. And look at the backstory. 2 decades synthesizing signal from noise for a particular advisory firm. Again, these are the short uh, descriptions I have given, but you should clearly have proper descriptive, verbose, backstory, role, and goal. Then I'm defining the 3 different tasks. One is for the topic and this audience, surface the 5 to 7 most relevant recent angles and use the search tool. I want a bullet list of 5 to 7 angles on that topic. Second, take each angle and validate. Maybe a tick mark or this is not valid, or maybe there is a warning which has to be validated. This is a fact checker. And this task takes the input from the previous task. The next, synthesization. This is going to verify the angles into a particular memo and look at what sections it should have. It should have a headline, takeaway, 3 supporting points, and 1 contrarian view. Again, you should specify what you want, how you want, maybe something that you don't want. Everything must be clearly, explicitly mentioned. Whatever you don't mention, again, the underlying model may assume something which is not relevant or of no use for you. What is the expected output? And look at this. This is going to take output of both these tasks, and work on synthesization. Finally, I built a crew, trend hunter, fact checker, analyst, as well as the 3 respective tasks. This has to be worked sequentially, not parallelly. And my crew is, first crew is ready. Second crew, this is going to be a writing crew. Here I may have a tech writer, I may have a reviewer, and I may have finally an editor who is going to polish that article. So writer is going to draft an article, reviewer will review it, maybe send back and forth, and editor in chief must need to polish and give a final go or no go, something like this. But we are going to take 2 agents, 2 tasks. So again, this is the one agent for writer, and look at the backstory. Maybe you are going as a staff writer or company engineering blog writer or some organization name you can clearly mention there. And Look at this. This is what I really liked this backstory. Your editorial bar is high, and you cut adjectives like a chef cuts onions. I like this analogy. All right, so we have a task for research memo to be created, which will take the research output and generate an article. So I'm specifying the word count. There should be hook, why this matters, three H2 sections, code block if applicable, and what to do as an action. This is call to action. Just don't write article or some piece where there is no call to action. So this is again a nice to have. Next task again, this has to be for the editorial part. Again, I'm building the crew with two agents, two tasks. This is again sequential. Did I execute the previous step? Okay, let me execute it. Okay, now comes the flow part. Look at this diagram. We are going to start with gathering a topic. Then we will start the research phase in which it can update the state object. Quality gate will is going to act as a router to check whether research is complete or it needs more. So it will go back and forth until the research quality bar is reached. And once it is done, it will send it to publish, where the second crew will take up the research output and create a polished article to be published. So this is our flow for the flow. Here I define a class, use the state, pydantic state that we have defined earlier. I may have few minimum, maximum, and other parameters defined. In the constructor itself, I'm specifying which LLM is to be used and what is the temperature. Then I am defining various functions with their events as decorators. So when this flow starts, it will start with this particular function. And again, I'm updating the status here and few of the parameters like topic, audience, and so on. Once this is done, research phase will start. Here, the entire crew of building a research, the research crew, we are going to kick it off, get its output. Again, that crew itself consists of multiple tasks, multiple agents. This is going to take some time. Once it finishes, we'll take the result and store it in a state variable. Then quality gate. This is going to check if the research word count or deepen count, if it is not matching or if it is matching or based on your quality gate parameters, you will say, okay, this is completed or it needs more. In needs more, we are going to do the research again. And this time when we pass the topic, we also mention that you should go deeper with concrete numbers. So you should add additional insight so that it can do actual deep research. All right. So again, I will skip this part. Finally publish. Here I will invoke the writing crew, kick it off, and I must supply what topic, what audience, and what is the research memo that was created by the previous crew. Once this is ready, I will take the output and store it in a markdown file in the current directory or wherever in whatever format you want to save it. You can decide this. And I'm returning the actual article as output of this entire flow. So let me run this. So my flow class is defined with internally it is using multiple crews. Each crew consists of multiple tasks, multiple agents. I'm creating an instance of the flow class and I'm using a plot method. Pay attention here. It is opens a web page and see how nicely it tells me the overall flow for this crew AI flow. I can click on it and it tells me whether it's a starting event or triggered by some other, is it router, and so on. All right, this is just a visual view of the entire flow. And now the time is ready to execute or kick off this entire flow. Let me run this, and it will also tell us in a nice fashion flow is flow execution is started. This is the starting method or starting function call with start event. It is running. Its flow is gather topic is completed. Research phase has started. This actually invokes a crew for research. Then it will pick up one or more task. For each task, an agent is going to work on it. For example, trend hunter is working on it. It may be using one or more tools. Then tool execution output. This is I said verbose equal to true so that you can actually get what is happening inside. By the way, you can also enable tracing, and I will show you what you can do to in case after deployment to production, you want to get the trace information. That also you can do easily. All right, so task is complete and so on. Checker has come into picture. It is going to perform its task. Tools will be called and so on. I'm just going to rush through it and let me see. Okay, look at this fact checker. It has fact checked a few out things. Then what else? Okay, agent final answer. Crew has completed. Next is research phase is completed. Next is writing crew. You can see here. You get to know what is happening inside that flow or crew. We are doing this in development environment, but you can enable tracing and you can see it uh, even for a deployed production application. So again, this crew is going to create a look at the research memo, and finally editor and so on is going to finally compile the output. Okay, and you can see the article is created in a MD file here nicely. If I click on it, this is the headline when it was generated, some summary, why it matters, uh, and other sections. There is a code sample. There are other sections also mentioned, and this is a call to action of a trending topic currently that it has found out based on the topic that we had mentioned at the beginning. Okay, and I can also print the output of this markdown file. So that is what I wanted to show you. Any question? No question? Okay, I hope everyone got it. Uh, if you are looking it at the first time, this might seem overwhelming, but trust me, if you look at this code and go through the documentation couple of times, you will be able to figure this out easily. Agent, how to define, task, crew, LLMs. You might have a question, how do I configure other LLMs? Again, you scroll down and you can see all the providers listed here, even from cloud. If you scroll down, Olama or a local NVIDIA NIM, you can configure any of these models. Okay, before you put into production, I'm sure some of the sessions earlier have already covered this, but this is very, very important. All the guardrails has to be in place. Any hallucination or anything deviating from your role goal should not be you should not proceed with that flow or crew. You should implement retries, circuit breakers, tool calls may fail, external API calls may fail. Next, observability. For this, let me just show you where and how you can configure this. You just scroll down to CrewAI tracing. You have to sign up for a CrewAI AMP account. You will have to do CLI authentication, then install this particular package. Once you do that, you just mention for a crew that tracing is enabled, or if it is a flow, that tracing is enabled. That's it. And on this EMP dashboard, once you execute the code or the Jupyter notebook, you will come to know that this is the place where this is a hyperlink. You can see it online, your traces for your application. Okay, very simple, straightforward. And I will give that as a homework for everyone to look at. Human approval. There might be human in the loop involved for various gates. Again, you should have them for any destructive or costly action. Any evaluation, evals you can create. There are various libraries available. You should do that for every agent as well as every crew. This will be part of your QA before you move into various environments. And finally, you can also can know about how much tokens or budget are you consuming when you execute a flow. So there is a property called usage matrix, and I think, yeah, flow usage matrix. In case you are interested, someone might be interested in knowing this. So this is the link for that. Okay, now is this the only framework? No, there are so many other frameworks. So when should I use Crew AI? Whenever you have to build AI agents where there are specific roles, specific goals, and whether either they will be sequentially executed or in a parallel manner. That time you should use Crew AI. But if there is some kind of a state and graph management to be used for traversal for these multi AI agents, Lang graph is more suitable there. If there are conversational chatty agents, then you can use AutoGen. If it is enterprise or leaning towards Azure cloud, then you should use Microsoft Agent Framework. If you are already have AWS as an environment, I think Strands is the framework or library you can use. If you want to use RAG first agents, where there is a more RAG involved, then you can think of this particular framework. Again, you should evaluate whether Crew AI or some other framework is suitable for my scenario or not. And even before that, the main question should be whether I really need to implement multi AI system, multi agentic AI system, or can this task be done with a single AI agent? Again, these are the two questions you should ask before you decide. Again, it is the same thing. So you can subscribe to my blog, you can connect me on LinkedIn, you can follow my GitHub repositories where I put code samples and for many scenarios. Any questions? I hope you found this session useful. Uh, and I tried to keep it beginner friendly so that anybody who has not used any such framework should be able to work on it.